All right, looking at ellipses, day 2 of conic sections. Standard form of the equation is either one of these. We'll talk about the difference in them in a moment. But first, let's look at just the h and k stuff. H and k is the center of the ellipse. That works the same as the circle does. So that is kind of standard. We're good with that. Another similarity to the circle is the plus sign. That'll be different when we get to hyperbolas, but for an ellipse it's a plus sign. And to me that makes sense. Like a circle and an ellipse, those are pretty close in terms of like just the shape, what they look like. So it makes sense that their equations should be pretty similar. Now, the big difference is instead of having equals r squared on the other side, like a circle, right, there's our circle. The circle has one radius. Here's the easy way to think of this. The circle has one radius. An ellipse has two radii, depending on which way you're going. And so if it's under the x, it's not a radius. I shouldn't really use that word because that's not what a radius is, but it kind of plays the same role. If it's under x, you go that many in x. And if it's under y, you go that many in y. So this one would sort of match up with that one. This one, yeah, B and A. And the deal is A is always bigger than B. That's how you know which one's A and B. But it kind of doesn't matter, because what matters is if it's under x, go that many in x. If it's under y, go that many in y. So rather than going r in all directions like a circle, well, we don't have a circle. We got a squished circle that has sort of different radii depending on which way you're going. So again, if it's under x, go that many in x. If it's under y, go that many in y. And you don't really have to be too concerned about exactly who's A and who's B. Let's sketch a graph here. X minus 2 squared over 16 plus y minus 3 squared over 25 equals 1. So the center, easy enough, I think, to pick on people. JD, what's the center of that ellipse going to be? 2, 3. So we'll go over 2, up 3. Again, you have to think it's an ellipse, so there's not one radius, there's two different radii. So Audrey put you on the spot. Very first one. How far left and right do you think we should go?
4 and 5.
Well, careful, you answered two questions there. Left and right, we should go 4. What do we do with the 5?
Go left 5?
5 is under the y. Which direction does y?
Up.
Yeah, up and down. So we'll go left and right 4. And up and down 5. So left and right 4, up and down 5. And notice we didn't even care which one's A and B. A is the longer one, but it doesn't really matter. If it's under x, go that many in x. So left and right 4. Up and down 5. And like yesterday, we're not drawing diamonds, we're drawing ellipses. So make sure your picture has some curve to it. See, the bottom half of that ellipse is pretty good. The top half is okay. Again, I'm not taking off for drawing unless you draw a diamond, and then I will take off. Letter B. little tight on space here. Ava, what's the center for the second graph?
-5, -3.
-5, -3. Austin, what do we do with the 9? I'll ask it differently here. What do we do with that 9? Or what's that mean to us? Okay, I get 3, and then what do I do with the 3?
Put it to the right and left.
Good. We'll go left and right 3. Toby, how about that 25? What do we do with the 25?
You go
Up and down 5. I feel like my ellipses are getting better. I feel like 3/4 of that one is good. And that bottom left piece is a little bit. That's okay. Graph C, third graph. Danny, what's the center of that graph? 6, 0. So another one of the zeros in there. 6, 0. Jake, what do I do with the 36? Okay, I square root it. That gives me 6. What do I do with the 6? Good. 6 left and 6 right because it's under the X. So left and right 6. A little bit off the graph. That's okay. Joseph, how about the 9? What do we do with that?
Square root it up and down 3.
Good. Square root it up and down 3. Perfect. Not quite symmetric, but you get the idea. Okay, a couple of terminology words here that I think make complete sense. The length of the major axis. The length of the major axis is the length of the longest part of the ellipse. Major and longest. The length of the minor axis is the length of the smallest part of the ellipse. So 2a, what is the length of the major axis in 1a above? So looking at the graph 1a, what's the length of the major axis? What do you think? 10. About the only wrong answer people give is 5 because they're used to using 5. And so they think, oh, that's the longer one, so 5. But the axis goes all the way across, so it's 10. And then the length of the minor axis, well, that was 4 on either side, so 8. So major, minor axis. All right, number 3, we'll try to work without graphing it. Evan, what's the center? 6, -9. Major axis length. Okay, we haven't really done one of these without drawing it first. Anybody tell already what the length of the major axis is going to be? 20. So the longer one is 10, but you got to go 10 on either side. So 20. The shorter radius is 8, but you got to go 8 on either side. So 16. And then is the major axis in the x direction or the y direction? And why is it in the y direction? It's like, cool, because that's where the bigger one was. So, yes. Let's skip number 4 because it's the same question. Every ellipse has 2 foci. That's the plural of focus. one focus, two foci. The two foci lie inside of the ellipse on the major axis. Always inside, always on the major axis. This next statement is kind of, you don't have to know it, but the sum of the links from the foci to a point on the ellipse is constant. So this is a little bit weird to think about, but pick any point on the ellipse, and the distance to the two foci is the same wherever you go. So I could pick that point, or I could pick this point over here. And you probably can't tell by looking, but if I did red piece plus red piece, that would equal blue piece plus blue piece. That's one way to define an ellipse. In fact, that is the definition of an ellipse. An ellipse is a set of all points in a plane, the sum of whose distances from two distinct fixed points called foci is constant. You don't really need to know that. That's where it comes from, but we don't really use that very much. We do want to find the foci, though. To find them, you use this equation. Now, this equation throws people off, because you tell me, why would that equation throw people off? What looks familiar except not about that equation? Right, it's like, oh, that's Pythagorean, yeah, a squared plus, a squared minus b squared equals c squared. So, be careful. For an ellipse, you use the minus. Hyperbola is different, but we'll worry about hyperbola when we get there. So once you find c, c is the distance. In fact, let's use that picture that's up there already. C is the distance from the center to the focus. So A and B are the sort of radii. Again, it's not really the right word, but the distance to the edges, the up and down edge, the left and right edge, that's A and B. C is the distance to the focus. Along the major axis. So you got to think about, well, is this an up and down ellipse or a left and right ellipse? Number 5. Find the foci of the ellipse with this equation. Well, it's very hard to jump straight to the foci. You kind of have to find a lot of the other pieces first. So let's walk through the pieces here. Brandon, how about the center for number 5? Where would the center of that thing be? Negative 3, 1. And even without graphing it, Austin, what does that 64 do? If we were going to graph it, what would we do with the 64?
Left and right 8.
Good. We'd go left and right 8. Ben, what do we do with that 100? What do we do with that 100?
You
Square root it.
yeah, square root.
And then what do we do with 10?
You times by 2.
Okay, he said times by 2, which is, if you were finding the length of an axis, you'd times it by 2. If I was graphing it, what would I do? I didn't ask the question well enough.
You'd go up and down.
Yeah. We can go up and down 10. So, is this an up and down ellipse or a left and right ellipse? Up and down, because we're going more. And so sometimes people will circle the up and down, like to kind of emphasize, hey, we're going up and down. Or they'll just do a little sketch of the up and down. So that means my foci are going to be up and down from the center. Foci are going to be up and down from the center. All right, c squared equals a squared minus b squared. All right, this is the only place where it matters who's A and who's B. But even then, it kind of doesn't matter, because if you get them backwards, it won't work, and you'll realize, whoops, that didn't work. A is always the bigger one. So 100 minus 64. C squared equals 36. So C equals 6. Let's kind of pause right there. If you'd gotten A and B backwards on this one, where would that show up, or how would that look? What would happen? It'd be negative. So it'd still be a perfect square, but it'd be negative. 64 minus 100. And you'd be like, well, I can't square something and get negative. And hopefully that's when you'd realize, wait a minute, I got the A and B backwards. So it's always the big one minus the little one. A minus B. Okay, so C is 6. And it's, well, C is 6. I don't want to say plus or minus. The plus or minus might help you remember to go up and down 6. Up and down 6. From the y coordinate, though, so negative 3, if I go up 6, 1 plus 6 is 7. If I go down 6, 1 minus 6 is negative 5. Again, because this is an up and down. Correct. We only want to mess with the y because our x coordinates are going to be the same for the center and the two foci. Which is why we need to do number 6, because before we answer anything, we can tell the direction of this one. Is number 6 left and right or up and down? And how do you know it's left and right? That's right. 49 is bigger than 36. So, yeah, we go left and right 7 and up and down 6. And I don't know why I use L and R and then an arrow for up and down. I don't know why I use arrows for both or letters for both. But yeah, it's left and right. The center, again, it doesn't ask me for the center, but the foci are based on the center. So, Noah, what's the center of that ellipse? 5, negative 8. And even before we find C, which of those coordinates are we going to be changing to find our foci? 5. We're going to be adjusting the 5 because our foci are left and right. All right, C squared equals A squared minus B squared. Again, it's just the big one minus the little one. So if you don't remember who's A and who's B, it kind of doesn't matter. C squared equals 13. This is the problem that Toby kind of anticipated a minute ago. Well, 13 is not a perfect square, so I'm kind of just stuck with 13. In some ways, this is even easier than the previous problem because I want to add and subtract square root of 13 to that 5 coordinate. So what would be an easy way to add and subtract 13 to 5? This is almost too easy. Just write plus or minus square root of 13. Because we want to go left and right by square root of 13. So x coordinate plus or minus square root of 13. Number 7, graph the ellipse with the equation. Oh, hold on, that's a different kind of problem. Any questions on foci, finding C, up and down versus left and right? Sometimes it works out nice, you get an integer. Sometimes it doesn't work out nice, but it's still easy to do because you just stick the plus or minus on there. And I hesitate to say it because some of you are going to do it, and it's okay. You could do the plus or minus thing on even if you have an integer. Negative 3, comma 1, plus or minus 6. That's fine if you want to do it that way. In fact, it's arguably better because it sort of emphasizes that from negative 3, 1, you're going to go up and down 6. So you can always use the plus or minus notation if you like. So some people, they like that and they adjust to that. Other people, like, they want to know what the coordinates are, so if they can add it, they will. Either way is fine. Number 7. Graph that ellipse, except that that's not in the right format. What did we have to do yesterday when it wasn't in the right format? Complete the square. Although this one has a couple of extra wrinkles in it. But let's start doing the same thing. Let's group the x's, leave a little space, group the y's, move that 64 to the other side. Jake, you with us back there? Because this is a little different. All right, normally we half it, square it, add it. We're still going to half it, square it, add it, but I can't do that just yet because completing the square only works when it's just x squared, when there's not a coefficient on x squared or y squared. So any ideas on how we could sort of fix the 9 there? Let's factor it out. And then same thing with the 4. Factor out the 4. Not only does it make it possible, it makes it easier because half it, square it, add it was going to be kind of annoying with 36 right there. Much easier with 4. So half it, we get 2. Square it, we get 4. Add it, I'll put plus 4 there to complete the square. But here's where one of the tricks is. I wrote plus 4 in that parentheses to make this a complete square. In fact, that's now x plus 2 squared. Still a 9 out front. I wrote plus 4, but what did I actually add to the left-hand side?
36.
Where did 36 come from?
You need to show that 9.
Yeah, so I wrote plus 4, but when I put the plus 4 there, I have to account for that 9, so I really added 36 because of the 9. So half it, square it, add it, but be careful when you add it because you didn't really just add 4. You wrote plus 4, but you added 36. Same thing for the y stuff. B over 2 is negative 4. Square that, we get 16. So I wrote plus 16 to make a perfect square, but what did I really just add to the left-hand side?
64.
So I'll add 64 to the right-hand side as well. So half it, square it, add it, but be careful on the adding. Oh, that's easy over there because the 64 is canceled. I'm left with 36. When we did circles, we'd be done, right? We would just say, oh, R is 36. There we go. But I got a 9 and a 4 over there. 36 on the other side. And if you remember, I want a 1 on that side. So what could I do to force there to be a 1 on the right-hand side? Divide by whatever's there. So let's divide by 36. And then the 9 and the 36 reduce. The 4 and the 36 reduce. And now we've got an ellipse in the right form. Thank you. So center at, Derek, what's the center of this parabola? Negative 2, 4. Go up to negative 2, 4. Landry, what do we do with the 4 in that denominator right there? Okay. And what do we do with the 2? Left and right 2. Gregory, how about the 9? What do we do with the 9? And then what do we do with the 3? Good, up and down 3. And again, it's an ellipse, not a diamond. And that question didn't ask anything about the foci, so I don't have to worry about finding the foci. It didn't ask major axis, minor axis either. All right, one more. So try number 8, and then I'll try to tail you by a little bit, and you can check and see as you go. Try number 8 on your own, and we'll see how it goes. We make it to here for the equation, but for foci, is this an up and down parabola or a left and parabola? Up and down ellipse or left and right ellipse?
Up and down.
How'd you know it was up and down? Yeah, the bigger number's under y. So I know it's going to be up and down. The center, Cole, what's the center of this ellipse? Negative 2, 3. So there's my center. The foci we just said would be up and down because this is an up and down ellipse. Luke, you just walked in, but I'm going to put you on the spot anyway. If I want my foci to be up and down from the center, which of these two coordinates should I adjust to get an up and down change?
Oh, the 3.
The 3. So I'm looking at the 3. Now I need to figure out how much to adjust it by, and that's where we use c squared equals a squared minus b squared. Here's a and b. Again, it doesn't really matter which one's which because you got to do the big one minus the little one. 4 minus 1. C is the square root of 3. So my foci, negative 2, comma 3, plus or minus square root of 3. And that would locate the two foci. So that's why that problem's last, because you kind of have to do everything before you can actually start answering the question of where the foci are. All right, today's assignment is worksheet 2. You've got lots of time to work on it.